In example 2, we have the graph of three functions, and in these three functions, for each, we're going to find the domain and range of each function graph below. Now, the definition of a domain is the x values, and the definition of range would be the set of all y values. Now, when I was in your shoes, it was always hard for me to distinguish um, the difference, just to remember that range was y and domain is x. So I've always associated this tail right here on the G with the tail of the y, and so I know that both of those go together. Range goes with y values. So let's start with domain, and domain is all the x values. So we are going to read the x values from left to right. And to do that, I've gotten this ruler image. I suggest that you get a piece of paper to help you follow this graph from left to right, or maybe a ruler. Maybe you're so good at this that you don't got to do that, and that's fine too. But if this is tricky to you, if this is something that gives you a little bit of trouble, just follow it with a piece of paper or a pencil or a ruler from left to right. Now, follow me for a second. We're reading from left to right, negative to positive, and our x-axis, I'm going to follow that with the ruler or the piece of paper. And you can see at negative infinity, we do not have a graph. But when we get to negative 4, we have a graph. And I keep going right. I keep going from left to right, keep going. I still have a graph, still have x values, still have x values, still have x values, still have x values until I get right here. And this point looks like it is 5. I was covering up the 4 there. So my range would be from that x value of negative 5 to positive 5. I'm going to use brackets because of the closed circle. That closed circle includes the negative 5 and the positive 5. We also have that closed circle at positive 5. Therefore, I have to use a bracket because the bracket includes that value. Now I have my same ruler, and now we're going to look at the range, and the range is y values. Now, I always say read from left to right, but if we're looking at y values, that's not left and right, that's vertical, that's up and down. So think back with me, when we read left to right, that is negative to positive. So I'm going to do the same thing on the y-axis. I'm going to read from the negative to positive. Okay, so I start off down here at negative infinity, and I go up, and I don't have a graph. I still don't have a graph. I go up, 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 and right here, I start having a graph. And that looks like an x value of negative 3. We'll write that down in just a second. And I keep going, and I have a graph, I have a graph, keep going, still have a graph, keep going, keep going, keep going. And once I get to the y value of positive 3, this has closed circles as well. Once I get to the y value of positive 3, I stop having a graph. So from negative 3 to positive 3 are the y values that are covered with a graph. So we're doing the same thing in the next part of example 2. We're starting with our domain, going to our range. Remember that domain is x's, range is the set of all y's, and we're going from left to right, and then we'll be going from down up, from negative to positive, basically with our range. But we're going to start with domain, and you can see that I start off in negative infinity, and I don't have a graph. I do not have a graph until I get to this value, this x value of what looks to be negative 5, where I have a closed circle. So I write that negative 5 down, but then I keep on going to the right and right about here something interesting happens. You can see that this x value that I'm looking at is -3. I'm going to leave the ruler there for a second. Now at the y value of +1 we have an open circle, but then we jump down to that y value of -4 with a closed circle. So since we go from that open circle to the closed circle on that same x value of -3, the graph continues. We still have domain. We still have graph, we still have graph, we still have graph, we still have graph, and then we stop. We stop here at the x value of -1. So we're going to write that -1 down and put a bracket with it because it's a closed circle. And now I'm going to keep on going. And from about -1 to +1, you see that there is no graph at all for our x values from -1 to +1. But then at +1, we pick back up with a graph. And because +1 is a closed circle, I'm going to write down a 1 with a bracket. And because I had that space, let me move that ruler so you can see that space. Because I had this space right here in the middle, I had to union them together. See, I didn't have a graph from -1 to +1. It skipped. So I don't account for it when I write down the domain. I just write a union where I pick back up with another graph. Okay, so we're at +1. We keep on going right, keep on going right. Still have graph, still have graph, still have graph, still have graph until we get to 5. I write that 5 down and it does get a bracket because it is a closed circle. And we have no more graph other than from -5 to -1 and then from 1 to 5 where x values are covered. Those are the only x values where we have a graph. But now we're going to look at range. And remember that ranges are y values. We read from negative to positive. So we got our ruler and we're starting off here at the bottom at -infinity, and we go toward the positive, we go up, and we start having a graph at -4. That -4 gets a bracket because we have a closed circle, and then we keep going up. We still have graph. We still have graph. We still have graph. Still have graph. Up here we got some weird things happening, but we never stop having a graph. Graph, graph, still have graph, and we have graph for all of these y values until we completely stop up here at this closed circle, and it looks like that's a y value of +6. So because that 6 is at a closed circle, it gets a bracket as well. So for our last function, example 2, we're starting off with domain, so we're reading from left to right, from negative to positive, and I start having a graph here at -5, and it looks like it's going to get a bracket. It gets that bracket because we have that closed circle at -5. And then we keep on going from left to right, and we still have graph, we still have graph, we still have graph. Here at the x value of -2, we have something interesting happening. Again, we have what looks like a skip or a jump. But we have that closed circle at the y value of +1, and then that open circle at the y value of +3. So since we have that closed circle and then pick back up with an open circle, we still have graph. We can keep going. So still have graph, still have graph, still have graph. All the way till we get to that y value of +5 that has a closed circle. Therefore, it gets that bracket. And now we're going to look at our range, which is our y values, the set of all y values. And I start at -infinity, but I don't have a graph, and I'm going toward my positive numbers, and I do not have a graph until I get to this y value of +1. And that 1 does get a bracket because it is a closed circle, and I keep on going, I keep on going, I keep on going to the top, and then I stop having a graph when I get to this y value of positive 3. And notice that I do have an open circle and a closed circle. Now, if they were both open circles, that would not include the y value of positive 3, therefore that 3 would get a parentheses. But because we do have one closed circle, at least one closed circle at positive 3 on our y-axis, then that 3 does get a bracket with it. Now, if you look toward the bottom of your page of notes, we just worked example 2. Example 3 will be your next problem, of course, but I believe the video may be labeled example 2. But it's going to match the problem that you have for example 3 in your notes.